Hello everyone. I'm going to demonstrate the development of the Reed Trumpet Mouthpiece 3D printed model. I have made a number of these by hand by using a trumpet shank, cutting off the cup, and then modifying a soprano sax mouthpiece to take the shank and then using epoxy inside to make the chamber small enough that it plays in tune on a trumpet. And I have access to a 3D printer now that my son left here, and I was looking for something useful to do on it. So, not that there's a lot of demand for these, but it was a neat project to work on. And I was originally going to start just by making a body, and then again putting the trumpet shank in there. But then I saw where some people make entire trumpet mouthpieces on these machines, so I went with an entire 3D printed design, and it works out pretty good. So I'll show you the development of that. The software I'm using is called Open Source CAD, OpenSCAD. It's free. It's not like a design drawing kind of software. It's a programming language that's geometric. So and it's got a lot of basic building blocks that you need to put together to add three-dimensional shapes and take away three-dimensional shapes. Okay, show you how much different this baffle and chamber looks like. Okay, I'm going to slice this in half. I have some code that I commented out that I just remove the comments and activate it, and then it slices it, and then I have to play with rotating it. Try not to overshoot it. When the model gets big, this gets a little clumsy. But anyhow, you see, here's the trumpet shank and a small throat, the baffle. Okay. This clearance ring is just if it goes on the trumpet too far, it gives you a little extra to push it on. Normally the trumpet sits out here. Okay, to show the different parts of this, I'll start with the body. There's a function within this software as you're developing it. If you use exclamation point in front of a command, it'll just do that line. So let's see, that wasn't exactly what I wanted. I'm not in the right spot. Okay, down here. Okay, there's the body that I started with. It's made in 3 sections. It's got a straight section here, and then this straight section looks almost straight, but it actually has a little curve to it. Then there's a lot of curve near the tip, and then that's rotated about an axis. Okay. Then from that we subtract off the facing. So let me go down to the facing and show what that looks like. Here we go. Well, that doesn't illustrate it as well as I like it from that angle. Okay. So if I take that command out, this is what the mouthpiece looks like. Okay. So the facing subtracts from that blue body this straight table and then the curve here. So what that looks like is that. This is a big block that you use to subtract, and you have to position it right, and then you take that away from the blue body, and then there's a curve here that I developed. Started out with circular facing, and later I threw an elliptical curve on there. Then the beak gets cut away. Okay. Now for the beak, I came up with like a circular shape here, and then rotated that and made kind of like a ring. Um, First, I'll show you what I guess those two circles look like. Again, I have to rotate to get them in view. Sometimes the rotation is a bit counterintuitive. Here we go. Here we go. Whew. There we go. So this is like where your teeth would be right here. So this is the surface that gets rotated and then subtracted off the tip of the mouthpiece. So what that looks like, we go down here and rotate it. Here's the orientation I had before. So your mouthpiece, it's this position about an axis way down here, and it gets rotated, and you subtract that away from the body. So if I get rid of that, that's the shape here. Okay, it's a lot of work, but and then the last is I added a trumpet shank here. I didn't design that from scratch. I probably could have. It would have been simpler. But what I actually did is I found a model online for free, and this is the second one I tried. The first one was too narrow, but I subtracted off the cup, and I just pasted all of that code into the middle of my code to create this shank. And what that looks like, if I go find where is the baffle, throat, trumpet shank, okay, right here. So there's the trumpet shank, and I used that, and then I tapered the end because I ended up running into my table, so I made that smaller. But that's built in. It already subtracts out the proper bore. Okay, what else? The baffle. I had to subtract out a shape to get the right amount of baffle in this part of the chamber, and also the throat. So there's your throat. So there it is right there. So that's all the basic geometry. Now, I took a bunch of measurements off a soprano sax mouthpiece and played with it until I got the ligature to fit right, and other things I liked about it. I actually printed about 15 copies of these that worked, and trying to get various aspects of it the way I like it. One of the biggest problems, let me get rid of this cutaway, is getting the, so you don't have to do a lot of handwork, is let's see, I might have did the wrong, okay. Let's try this. Hey, good. Is trying to get the reed profile to be made properly. So I started out by actually putting a model of a reed in here, and then I later changed that to something that was just the outline of a reed, so I could see where how the edges of the mouthpiece match up to a straight line. And right now they match up really well, but I had to play with that a lot because of all the geometry choices that go on. Okay, and I'll show you a few of them. One of them is like the reed angle, how much it is angled in the facing. So let me find that. There are a lot of parameters here that I can play with, but only a few of them that I really had to play with. So if you change the reed angle from 3.5 degrees to 3 degrees, it wasn't that big of a change. All right, let's do it again. Let's go down to 2.5 degrees. There we go. So you can see it doesn't cut into the mouthpiece body as far as it did before. Now if I raise that up to like 5, it cuts too much, and you get a wider body than your readout line. So this is primarily to size this back table section of the mouthpiece. Now the other part of the mouthpiece has to do with the shape of the body in this area, which has to have a slight curve to it, like I mentioned before. I started using a straight line, and then I went to an ellipse, and then right now I'm using something that's called it's a mathematical Bezier curve, Bizet, however you say it in French. So I actually borrowed some code for that. Let me see if I can get this to rotate around. Okay, there you go. So this is kind of like the curve, sort of, that I used in the mouthpiece. This blue line, the red is just an illustration. So this allows me to position the red dots around to get different shapes here. So I embedded this code into that part of the body so that I can play with the position of this point. If you move this, let's say up, it bends the blue line, the curve. So you reposition this point however you like, make it longer, and it changes the shape so that you can dial in how well it fits the reed. Going back to my model, which is now probably not the right orientation again. Trying to none of these standard views are going to give me what I want, so. Okay, I lost it. Here we go. Rotate, 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 rotate. Okay, there we go. Fine, so to illustrate what I was talking about, that's the body in this area. I'm going to change a couple of the parameters, if I find them. So, like if I wanted to make that part fatter, move that point out like I was showing, it'll make it fat in that area. Okay. Likewise, if I went down to 0.3 inside, it's too narrow. So you can kind of dial in the shape from where that point is located. Other thing to fix is the tip rail. I actually print out a model of this with no tip rail because I have to do some hand finishing on the to get the ridges out, and it creates a tip rail. But I have a couple of adjustments built in for the tip rail shape and thickness. So for a while there, I was actually printing out a tip rail, which I have an adjustment for that. Did that go the right way? No, it didn't. Come on. Trying some numbers here. They don't work one way, you try them the other way. So it's supposed to be a tip rail adjustment, but I'm having trouble getting it to calculate. It's calculating something. Oh, I'm pressing on the wrong button. Duh. Okay, you can see you can make it thicker. And get it down here. Okay. 1 point. So I could dial it in. I had it somewhere around, I think 0.9 would give a thin tip rail here. Oh, almost no tip rail. Oh, the other is to get a smoother curve, I have to put in 200 segments instead of 100. So I'll go back down here. Okay, now change this to like a 1. Yeah, there's a nice thin tip rail there. I've got a factor for how wide I want to make the tip opening. I may try some wider ones. It makes for a louder sound slightly, but trumpet's so loud you really don't need it. The other is this curve shape here. This can be adjusted. I have parameters in there for all that. For instance, this one right here, slowly updating. This is like a radius of the baffle shape, the way it's dished out here. So you can see it's now thick in the middle and thin on the edges. And if I go down to like here, it'll go the opposite way. See? So, yeah, it's just another thing that I can mess with. Did I have it there? 3. Okay, so after you're done with all this and you have a design that you like, you got to turn off any of the guides you have in there. Like I have to turn off this my code for the read outline. Okay, and I got a little discontinuity there, so I may have messed something up, but it's good enough for the video, I think. Demonstration. I might have not changed one of my numbers back to where it was. But at this point, you have to go render it to create an STL file. And that takes a long time. That takes about 5 to 10 minutes, depending on how powerful your computer is. Could take longer. So that's a button on here. So I won't show that. Afterwards, then you have to go to a slicer, which takes that STL file. I'll load that on top of here. Hopefully we'll see it. This is, again, a piece of free software. Okay, we're back, and now I'm inside Cura, which is a free slicer that's pretty popular for creating code for the printer from your solid model. There's a lot of settings in here. Most of the defaults are pretty good, and you get a lot of control over what you do, how hollow you make it, or make it solid, how thick you want the wall thicknesses, speeds, and how the sizes of layers. The only problem I had is when I was using, I used most of my models have a 25% infill. If the wall was real thin, the default thickness, you would see a little waviness on the outside. So as long as I stayed with around a 1.8 millimeter wall, a shell wall thickness, I'd be okay. So had to plug that in there. The other thing is you can see it's when the printer gets up to this area, it can't print. It starts at the bottom, it builds this up, and then doesn't have anything to print against when it's gets to this area. So you need to have a support that's a throwaway support, and that's built into the model. The normal support I'll show here that comes up was more than I needed and difficult to get off and messed up the body more. So let's see. Got this. Because this isn't full screen, it's not showing me the slice button. There it is. So now I hit the slice and it creates the code very quickly. Then you hit a preview, and that would be what it's going to print out. The red is what you want to keep, and the blue is the throwaway stuff. So it's a lot of ribs that are around there that would get thrown away. Okay, what I actually did is I went in and I changed the support from what it was normal to tree. Okay, I re-sliced it. It doesn't look much like a tree, but it's just, I guess you needed some kind of name. So there you go. It is more of a skirt kind of a thing that goes around it, and breaks off easier, does the job. So that's what we went with. Then from here you save the file, and it creates G code that you have to put on a SD card that you load into your printer, and then run the job from there. So I'll go down and show you I'll show you some of the printer in operation, and then looks like and how it plays. Okay, that is the printer I'm using. It was a Kickstarter effort from JG Maker for this dual extruder that kind of made my son interested in it. There's a Facebook group for this, and they're not real happy with it, especially the early ones that came out, because they kind of shipped it while having lots of mechanical problems. The one we got is pretty good. We really haven't had problems they've had. Artist D is what the model is, and we haven't done much two-color printing with it yet, but maybe in the future. And this is a photo of an original Eddie Harris reed trumpet mouthpiece. I had some good photos of one of these. I never saw one up close, but I modeled my chamber work after some photos. So the patent ran out on these, 30 years ago or so. Okay, here we are. This is how it is. You scrape it off the machine. It's got that skirt around it. And I'll show you how it comes off. Let me do it this way. Just grip it with pliers right underneath and give it a little twist. Plunk. That's easy enough. You end up with a little edge here that you got to take off, and I don't try to get a perfect bottom, but I do clean that up a little bit better. I always come out with, for some reason, and I don't know why, a couple of irregularities in this area that I just file out. And there's occasionally there'll be a little blob around the logos. There's a ridge across the bottom here that I have to file off. And that's where the skirt was connected along, I guess, maybe the back side. There was a support there. So, but all in all, I really like how these, are coming out now. I don't know how to make this facing any flatter other than hand finishing. It's got like a lip around all the corners. And maybe I can play with temperatures or whatever to try to get that, not to happen as much as it does. But I have a feeling I'm still going to have to do some hand finishing, so it's not that important to me. It's more important that this line matches the reed, which it does. If I can find where I put the reed. No, my test reed Ligures are kind of clear, so I'm real happy with the way that all fits around there. And I've refinished a number of these along the way just to make sure that the facing is what I want it to be. In fact, here's one now. What I do is I don't try to get all the ridges out, but I do face it enough to where it doesn't leak air anymore, and takes about a dozen swipes or so. And I like to wrap Teflon around the end. It may work fine without it, but the trumpet I'm using is a junker, so it's a bit irregular. And I like a rubber patch. This is designed to be used with a inexpensive, 2-screw metal ligature. This is made by what do they call American Plating, that a lot of people resell for like $8 or so. But I also recently, just today, in fact, printed out a couple of ring ligatures. I don't like the concept of these because, you know, to me they might slip and stuff like that. They're not adjustable, but actually, you know, both of these are about the similar taper. One's just a little rounder, I guess, to hold it on there. But these work pretty good because the mouthpiece has some ridges on it, and these kind of ratchet on there. Pretty tight, so I don't think that's going to slip at all. Maybe over time things will get worn smoother and it may not work as well, but you know. Oh, here's my junker trumpet. Harmon mute is a good idea. It gives resistance and makes the sound more pleasant because it's a really bad trumpet sound. Maybe you can practice and make it better, but I don't really have the desire to. I just like to make them, not play them. So, you know, that I test them, make sure that they get the overtone series. I think if you do long tones, just like, you know, treat it like any other instrument, you'll get some muscle memory to hit the notes better. Find your embouchure point, you know. And of course, playing with reeds. That's what I didn't mention. I do all my facing development with a Ligature original cut 2 3/4. It'll work with other reeds, but just that's what I like because I want to be able to pick it up and play it without wetting a reed, and I want the reed to change over time, you know, though these do change after about 20 minutes of playing, but they're more consistent. So, you know, practice. That's what it's going to take. But it does have potential. Oh, and yeah. So does that ligature. That ligature. It's not bad at all. So I'm getting some gold filament in. I'm going to be making some of these. I'm not going to try to price them too high. I may even sell some prototypes at a discount. Stay tuned. If you see them on, I'm not going to make any money off of these. I've got a lot of time invested, but it was a nice little project for me to learn how to use, you know, the modeling software and the printer. So I'm happy for the experience, and now I'm going to be able to apply it for a lot of other neat things. I don't plan to make mouthpieces on it. I'll make a few, but maybe some bass clarinet, contrabass clarinet ones. But I'm all set up for my own use, and you know, so we'll see.